Hello, good morning everyone, and welcome to my talk on testing made sweet with a Mockito. Let's start with a small little word about myself. I'm Jeroen Mols, I'm Belgian, and I work for a small company called Philips on the connected hue lighting system. I'm also quite active on Twitter, so feel free to hit me up with any questions, should you have any after the talk, or to follow me, obviously. So this is a talk about testing. So then the first question we should ask is, why should you write tests? Maybe a small question for the audience. Who here writes unit tests for their code? All right, that looks really good. Well, it's important to write tests because, yeah, if you don't like testing your code, why would anyone like testing your product, right? Should you not be writing tests? Then the best way to get started is to stop fixing bugs. But instead, first write a unit test that reproduces the bug, and then just go and fix that unit test. Because if you do so, you're not only sure that you fixed a bug, but you're also sure that that bug never reappears again. Now, today we actually want to do something fairly simple. Imagine a very basic application. We have some UI, which has a button, and if you press the button, the UI will do a login request. And that will then actually create a user object, called a login method on the user object. The user, in its turn, will talk to a web service. The web service will do the login request. Somewhere in the future, that web service will, respond with success or failure, notify the user of that, and as a result, the user should update UI. This hopefully looks fairly familiar to all of you. Now, what we want to accomplish today is, some way or the other, we want to completely isolate the user object and fully test that. Okay, simple enough? So let's try and do that. But before we actually can do that, we need to have our tools. We need to have our tools set in order. First things first, we're writing unit tests, so what makes a unit test good? First, your unit tests need to be fast. And I'm not talking about your unit test should run in a second. No, I'm talking insanely fast, ludicrously fast even. You should be able to run hundreds, if not thousands of tests in under a second. And why is that so important? Because the faster your unit tests are, the more likely you're going to be running them. And the more you run your unit tests, the more value you will get from them. So having fast tests is really, really important. Secondly, your tests should be small and focused. By small, I mean physically small. They should only be a couple of lines of code, right? That's no different from your normal code. You should be able to look at a test and immediately understand what's going on. But they should also be focused. By focused, I mean that every single unit test should only test one specific part of your code. Or, if you turn it around, should you have a bug in your code, then only exactly one unit test should fail. So you don't want to do multiple assertions in one unit test. And then the last requirement is your test should be reliable, as in non-flaky. This is also really important. And why is that? Because if your tests fail, that should be your top #1 priority you're going to fix at that point in time. You should drop everything, go about and fix that unit test. But now imagine that the test just failed randomly. So what you're going to do is you're going to drop everything, you're going to go and analyze why it went wrong, you're going to look for a bug, but you can't find a bug, and then in the end you're just going to decide like, okay, let's rerun things, and magically everything works again. Now, that might not seem like such a big a deal, but over time, you're just going to stop caring about those failing tests. You're not going to have the urge anymore to really go about and fix everything when a test fails. So they should be reliable. If something's wrong, then you can go and fix it, and that should be something which happens only rarely, obviously. Now, if we map that onto our project, the main difficulties in testing this is the UI, because testing UIs, as for instance on an Android device, you need to instantiate the UIs. Well, that's gonna take time. So they're gonna be slow, so we don't want to test the UI. And the same with the web service. Web service is always gonna be slow, and also, talking to the internet is inherently unreliable. So also there, we don't want to test the web service. Cool. So how can we actually do that? Well, we're going to isolate the user object. First, look at our architecture. So we have a clean architecture. Our UI depends on the user depends on the web service. But there are no dependencies the other way around. So the user is not dependent on the UI, nor is the web service dependent on the user. Because of that, we don't have to include the UI in our test. We can just immediately start invoking methods on the user. So okay, that's solved. Second problem, the web service. Well, that's slightly trickier because obviously we want to have reliable tests, so we don't want to do the network requests in our unit test. So what we need to do there is we need to replace the web service by something that looks the same but behaves differently. And then instead of actually verifying results to state verification, we're going to verify the interactions to behavior verification. Okay, so this brings us to a definition called test double. A test double is exactly the same as a doppelganger. It's somebody who looks a lot like you, but just isn't you. So we replace the green web service by an orange web service, which looks exactly the same, but has a different behavior. And that actual behavior of that dummy or of that test double can differ. So instead of doing the normal implementation, it could simply do nothing. Or it could always pretend like the network request was successful. Or it could throw an exception and do something completely different. Well, in reality, you actually have more than 2 test doubles. So you have quite a lot of test doubles, but the 2 main ones are mocks and stubs. I'm not going to cover those other ones because I just find them to add more confusion than they actually should. So, what is a mock? A mock is typically an automatically generated class. You ask some kind of framework, hey framework, create a mock for me. And that framework will then create a new class which looks exactly the same like the other class, but just doesn't do anything. So every void method won't do anything. Every method with a return value will return the default value for that type. So a method that returns a boolean will return false, that returns a string, null, an integer, 0, and so on. But the one thing a mock does do is it has counters internally. So it can remember which methods were actually called on it. So later on, you can actually verify that a certain method was called on that mock. That's behavior verification. Now, on the other hand, we have a stub. A stub is typically something you write yourself, a handwritten class. And what you're going to do is you're going to hard code, program some behavior, so you're basically going to return predefined responses given a certain input. And that then, because a stub actually returns values, also allows you to do state verification. So we have 2 main things, mocks and stubs, and that's also something we're going to use a lot today. Now, we have our tool set in order, but it's time to look at our framework. And our framework is called Mockito. Who here knows Mockito? All right, great. Well, then this won't be any surprise for you, I guess. It's an open source framework that allows you to write beautiful tests with a clean and simple API. It's on GitHub, the source code and the documentation, and it has a very friendly MIT license. Now, why would you drink it? There's 2 main reasons. One is its ease of use. So it almost has no learning curve. It has a very clean, simple syntax, and it also offers annotation support to make your tests even more readable. On the other hand, it's a very mature framework. Mockito is, and has already been, for a couple of years now in the top 10 of most popular Java libraries. So there's a huge community on Stack Overflow, and should you have any question, you can always go there and find the answer to it. So how do you drink it? Well, Mockito is deployed to JCenter or Maven Central, I don't really know. But anyways, JCenter is a superset of Maven Central, so if you include JCenter in your build.gradle file, you could just pull it in by specifying a test compile dependency. As of today, the latest version of Mockito is 2.2.11, which means Mockito has reached its 2.x stable stage, and I'll talk a bit more about that later in this presentation. Okay, so that's that. Let's now look at the ingredients of Mockito. Well, there's multiple things you can do with Mockito, and what we're going to do is we're going to just start at the basics, and then we're going to build it down incrementally to more advanced use cases. So first things first, what do you want to do with the mocking framework? It's creating mocks. I told you Mockito was easy to use, and you can see I didn't lie because creating a mock is only a few lines of code. Basically what you do is you just ask Mockito, hey Mockito, create me a mock of this class. For instance, here it creates a mock of the web service class, and the mock web service is something which has exactly the same interface as the web service, but if you call a method on it, it won't do anything. If you call a method that returns a value, it will return the default value for that type. Now, there's actually a second way of creating a mock. No. First, a small side note. So, Mockito relies on static imports, so the mock method of before is statically imported. Now, there's a second way of creating mocks, and that is by using annotations. What you basically do is you just create a public field. A field can be public or private, doesn't matter. You annotate it with @mock, and then Mockito will initialize the mock for you. There's one thing else that you need to do, because if you have used any annotation processing framework before, then you know that those annotations don't initialize themselves. So you have a couple of options. Either you just ask Mockito and you tell it to like Mockito annotations dot initialize, and then it will initialize all of those annotations for you, or you can use a test rule. And I actually recommend using the test rule because that's cleaner to use. And also what the test rule will do is it won't only initialize all of the annotations, but it's also going to verify that you're correctly using Mockito. So we'll see later on, Mockito makes use a lot of fluent syntaxes. So that means that you could forget to append the last part of the syntax, and Mockito is smart enough to be able to detect that. And that's also something this test rule will do for you. To add the test rule, that's really simple. You just create a public field. Now it does have to be public. You annotate it with @rule, and you initialize a Mockito rule in it. So you say Mockito JUnit.rule. Okay, so let's verify some interactions. Have a look at this very, very simple test. It has a very basic, clean structure, AAA structure. So first we do some arrangement where we create a new user. Then we do an action, we call logout on the user, and then we do an assertion to actually verify that the logout method was called. Now, this is where we actually do the verification. So, to verify that a certain method is called on a mock, all you have to do is ask Mockito, hey Mockito, verify that on this mock, this method is called. It's nothing more than that. You actually have a couple of options if you want. You could specify the amount of times that you want that method to be called. You could say like, I want this method to be called exactly once, or at least so many times, or I want this method to be the only method to be called, or I want this method never to be called, and so on. So you have quite a bit of power to specify how many times you want this method to be called. By default, Mockito will actually use the ×1. So in the previous example, if you don't specify anything, it's just gonna take ×1. Now, be a bit careful with this, because if you're gonna be, overly restrictive, you're gonna make your tests brittle. Imagine this use case. We're testing the login method. Well, you could say like, when somebody logs in, you don't want them to log out immediately after, because that wouldn't make any sense, right? So in your login test, you could, next to doing the verify that the login method is called, you could also explicitly verify that the logout method is never called. Well, that's actually a really poor idea. And why is that? Because in reality, you're not going to have one login test. You may have 10 or 20 login tests. Login with user ID null, login with invalid user ID, login with correct user ID, login with password null, and so on and so on. So you're going to have a test for all of those cases. And should you also explicitly add the case, never call logout to all of those tests, well, what's going to happen then is, if you later do decide to allow this, for instance, you're adding a wearable support to your app, like Android Wear, where it may make sense to immediately log out after login to conserve battery, well, if you want to make that change, then you would have to go about and change all of the tests you wrote for the login. So you really don't want to do that. Don't be overly restrictive. If that's a use case you find important, just write a single test for it. Logout should never be called immediately after login. Put the code in one test, and then if you later change your use case, you just have to go and fix one test. All right. Now, what if a method takes parameters? For instance, the login method takes parameters. You can just add those parameters. You can't just do that. You can also be a bit more vague about how you want the parameters to look like. So you can say like, hey, Mockito, I want this method to be called, but the parameter can be, I don't really care. It can be any integer, any string, or any object of this class. This is what Mockito calls a matcher. And why is it important to know what a matcher is? Because if you use a matcher for one argument, you need to use a matcher for all of the arguments. So here, if you use the login method, if you say like Mockito verify that the login method is called, and the user ID can be any integer, then you need to wrap the exact password with an equals matcher. It sounds a bit artificial, and that is because it is artificial, but don't worry too much about it, because if you don't do this, Mockito will throw a friendly warning reminding you that you should do this. Now, there's even more advanced matchers like greater than, less than equal, or string matchers that you can say like, oh, string should start with this value, or accord to this regex. And even crazier stuff like it can be any object of this class, but it should not be null, or it needs to be between those two values. Out of the box, Mockito has two classes where it defines all kinds of matchers you can use, Mockito.matchers and Mockito.additional matchers. So you should find a matcher for every one of your use case. And if there's not, you can also extend the matcher interface yourself, implement it, and then you can write your own matchers. We will actually do that later in this presentation. The last thing you could do with verifying interactions is verify the order in what methods are called. So here we call first login, and then we call logout. Well, then we actually want to verify that the user also calls these methods in that order on the web service. So we just ask Mockito, in order for this mock, verify that first this method is called and then that method is called. This works for different methods called on the same mock or for different methods called on different mocks. All right, stubbing methods. Well, remember when I said if you create a mock, then every method that returns a value will return its default value. So if you look at the mock web service that is offline method, if you don't do anything, that method will return false, because that's the default type for a boolean. Should we want to change that for our test, so should we want to stop the behavior of that method, we can. We just ask Mockito, hey Mockito, when on this mock, this method is called, then return that value. So when on the mock web service, the isOffline method is called, then return true. And when that returns true, we can then verify that the user never calls the login method on the web service. So this is quite powerful actually. You can't just stop one invocation of the method, but you can also stop multiple invocations. So you could say like, the first time this method is called, return true, second time false, and then all of the subsequent times true again. Or you could even say like, hey, throw an exception. So have completely different behavior. Or you can even go wilder and specify a complete answer to be returned when the method is called. Well, I'm not going to cover this in depth because I don't really recommend you using this. This is really nice because in your answer, you can also look at like, the parameter that was passed along to the method, and then, according to the state you're currently in and the input parameters, then you can decide to return a particular value. Now, I'm not covering this in depth because what this basically means is, if you think about it, you're hard coding knowledge of the rest of your architecture into that one test. So I don't really want you to do that, because if you do that and you change the architecture later on, then the test is gonna break because of that. So you know that it exists, you can look it up on the internet and see and use it if you need it for a use case. I personally also admit I sometimes use it, especially if I'm testing against a third-party library of which I have no control of the interface. And if the interface is inconvenient for testing, then sometimes you need to jump to a couple of hoops to make it work. But this should not be your default go-to stubbing method. Okay, so stubbing methods has multiple syntaxes, and the default is, hey Mockito, when on this mock, this method is called, then return this value. But you also have an alternative syntax. Hey Mockito, do return this value when on this mock this method is called. And then you might ask, what's the difference? Well, this syntax is actually slightly inferior. Because first you have the return type and then you have the method invocation. So this syntax is not type safe. Mockito cannot infer the return type of the method when you're using this syntax. Why would you use this syntax then? Well, if you're working with spies or if you want to override a previous stubbed method, then you can use this syntax. So again, this should be something that you rarely use. Mockito does have another interesting syntax, and that is the Bdd syntax. It's exactly the same as the when syntax, but it's just renamed to make it a bit more Bdd-like. So here you say like, given that on this mock, this method will return that value, then on this mock, this method should be called exactly so many times. So if you're into Bdd, then this might be an interesting thing to look at. Okay, capturing arguments. This is a bit more difficult to explain, so bear with me. Let's go back to our problem statement. So what we basically do is, we call login on the user is going to talk to the web service, but a web service cannot respond immediately, so it's going to return an asynchronous result. It's going to return a success or failure via a response object to the user, and then the user is going to update the UI as a result. What if we want to test this exactly? So we want to test that, given a response of the web service, that the user updates the UI properly. Okay, let's zoom a bit deeper and see how the login method on the user looks. Well, inside of the user, so inside of the login method, this is a method on a user class. The user will create a new response, which is an object it passes along to the web service. And the web service is going to use that response to provide the feedback about the success or failure. Now, if you see how the response class looks, in the onRequestCompleted method, we have a very simple logic, which just, if it's successful, then call the onLogin success, or otherwise call the onLogin failed. Now, it's exactly this logic that we want to test. So given that the request is completed successfully or failed, the user should call the right method on the login interface. Now, how can we test this? First, we're going to invoke login on the user, so the user does the login call on the web service. Well, when the user does that, because some way or the other we need to get a hold of the response object that the user creates internally, right? So when the user calls a login command, then we're just going to intercept the object it created internally and pass along to the web service. And once we have that, we can simulate the success or failure, and then do the verification that the user updates the UI accordingly. Well, this is how it looks like. I'll talk you through it step by step. It's not as difficult as you might think when you see this. So step 0 is to initialize a new object called an argument Captor. This is also one of the native types of Mockito. And what you basically do is you annotate a member with @Captor, and then you specify what type it's going to capture. So this is a response captor, so it's an argument capture, which can capture an argument passed to a method of the type response. Once we have that, we're going to do step 1. So just invoke the right method on the user object. So the user now is going to internally create a response object and call login on the web service. And then we're going to verify that the user actually called that login method on the web service. And now you might think, whoa. You said before, like 15 minutes ago, that you should never do more than one assertion in a unit test. And now you're doing it yourself. Well, yeah, that's true. But this is just the way how it works. In this case, we're not doing the verification for the sake of actually checking that the user called the login method on the web service. No, we're doing this verification just to get a hold of the parameters passed to the web service. So to do response captor.getValue, then we actually capture the response object passed by the user to the web service. So once we have the response, we can invoke its method on it. So now we pretend like a network request is successful, and then we can just check that the user updates the UI accordingly. All right, so this is an extremely powerful mechanism, especially to test asynchronous logic. I use it quite often for that, but please don't overuse this, because many of the use cases where you might use this for, you could also solve it with, for instance, a matcher. So then, yeah, it's not because you have this power in your control that you actually need to use it. Okay, so Mockito 2 comes with a few limitations. It cannot mock final classes and methods, but fortunately, Mockito 2.0 does bring that power. It's still an incubating feature, so it's not turned on by default yet, so you need to opt in, but I'll show you later how you can actually opt into that. So basically, the only limitation that still remains is mocking static methods. That's something Mockito cannot do. Then the other things it cannot do is private methods, but yeah, why would you want to test a private method? And also hash code and equals, I don't really see a use case for that either. So let's do some advanced Mockito now, the Raspberry Mockito. Again, a plethora of topics we want to cover. I think the most notable ones are going to be testing the UI, how you can go about testing final and statics, and then also maybe a custom matcher. So testing UI. Remember what I told you before. You don't really want to test UI, or at least we didn't want to do it in this example. And the reason I gave you for that is because UI tests are slow. And that's always going to be the case, because initializing a UI always is going to take more time than initializing just normal code, especially if you use Android, because then you have to run your tests on a physical device or an emulator, so you have like the deployment step, the install step, and so on. Now, so given that we don't really want to test UI, how can we then still make sure that our app is properly tested without really having to inflate the UI? Well, the way I do that is I separate all of my view and view logic from each other. So not make one class with the view and view logic. So you can completely test the view logic and you don't have to worry about the view. A really nice paradigm that I find for this is MVP, Model View Presenter. It works very, very simple. You just have a view interface, so you create a view interface, and there you specify like, these are the methods that the presenter can call on the view. Then you have an implementation of that interface, which is typically your activity or fragment on Android. And the first thing that implementation is going to do when it's created is create a presenter. And it's going to pass itself as a view interface to the presenter and also pass the model to the presenter. So then, whenever your UI gets initialized, the first thing that's going to happen is you're going to create a presenter and it's going to get all of its dependencies injected to it, which is great for testing, right? And then, so that's the first reason it works, dependency injection. The second reason why it works is, again, because this is a clean architecture. All of dependencies only point in one direction, so the view implementation depends on the presenter, but the presenter does not depend on the view implementation directly. Now, should you adopt this, what you basically do is you dumbify your UI and just reduce it to merely a pass-through layer. For instance, the view interface would define a method setProgress, and then the implementation in the view class, so in the view implementation would be progressBar.setProgress with the same parameter. So I personally don't test that logic anymore, because what you would basically be testing is just if the Android framework or whatever UI framework you're using, if that works. So I accept that I don't really test that. What I would do instead is just write a couple of integration tests for the common flows in your app. I think there's more value in doing that than actually writing tests for that dummy UI that we have here. A second remark I want to make here is, please, please don't be dogmatic about this. In the Android community, there's a lot of talk like, yeah, you need to do model view presenter and you need to do it like that. No, 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 no. It doesn't matter what you do as long as you're consistent about it. For instance here, this is MVP, but it's not textbook MVP. Ideally, I should have also made an interface for my presenter and an interface for my model, but I typically only have one presenter or one model, so why would I bother doing that? But that's my opinion. If you have a different opinion, by all means, create your interfaces. The only thing you should take care of is that you and the rest of your team are doing the same thing. So be pragmatic, choose as a team what do you want to test, how do you want to test it, and then try to be consistent about that. Okay, what if you want to run Mockito on an Android device? That's possible. So if you take a step back and see what we've done so far is, we were always running Mockito in a JVM. Now we're going to run it on an Android device. First thing you need to do is configure the Android testing support library, so you have JUnit 4 support. And then you just add the dependency on Mockito, and that's it. Now, maybe you've noticed that these are a couple of more dependencies than we had when we were using Mockito on a JVM. And the reason for that is that the way Mockito works is it's going to generate classes at runtime for you. So if you're running your test and you ask Mockito to create a mock, on the fly it's going to create an instance of that mock. So it needs to be able to create a class. And the way you create classes is different in a JVM than it is on an Android device, because Android has their own virtual machine. So Mockito cannot do that out of the box. How Mockito solves that is by using a tool called TextMaker, and that's basically that offers the ability to Mockito to also generate classes on an Android device. It's a great tool, it's stable, you can use it. The only disadvantage of it is that it's not really actively maintained. So I think the last commit was about a year ago, and that means that it's not yet compatible with Mockito 2.0. So that means we're stuck with Mockito 1.x on Android. It's not a major deal because all of the things that we already discussed up to this point, those are also possible in Mockito 1.x. So Mockito 2.x didn't bring many interface changes, basically. Yeah. The good thing about this, by the way, for the Android developers in the room, is that because Mockito is only a runtime thing, it doesn't have a compile time step. And if we then very soon move over to the new Jack and Jill compiler, well, Mockito isn't gonna be bothered by that. So Mockito will still continue to work on the new Jack and Jill compiler. All right, so let's write a custom matcher. Mockito out of the box provides a lot of different matchers. Hey, remember a matcher, that was a thing that you could use to verify that a certain method is called with then certain parameters. There we were using matchers to be a bit more vague about what the parameter could be. Mockito offers a lot of matchers out of the box, but for instance, a matcher that it doesn't provide is to check if a list contains a certain value. So let's write that ourselves. So this is the list contains matcher. The way you create your own matcher is you first implement the argument matcher interface. And the argument matcher, you can see the generic type I defined there is list. So there you need to specify like, okay, this is going to be a matcher for a method that takes a list as an input parameter. Okay. Then also mind the generic that we added to list contains so that our matcher isn't tied to a particular object. Now, the first thing we're going to do is add a new constructor and inject the object that we want to test for in the list. We need to keep track some way or the other of that object so that when Mockito actually does the verification, we have the object to test for. So we keep track of the object in the constructor, and then this is where all of the magic happens. When Mockito evaluates the matcher, it's going to call the matches method, and then it's going to pass you the parameter of the method. So you're going to get the list, and then you can simply check that the list contains the object, which is quite straightforward. Then a final thing you need to do is add the toString method. This will be called is if the matcher evaluates to false. So should your test fail, Mockito is going to call the toString method in order to print a proper error message. So here you just have to return, an error message. For instance, list doesn't contain object. Now, in order to use this matcher, that's slightly counterintuitive, or yeah, let's say not really intuitive. So what I recommend you to do is to create a new class where you're gonna define all of your matchers. So here I create a new class, list matchers, and then you add a static method for every matcher that you have. So for instance, here I create a static method which will return our list contains matcher, and then that static method will wrap around, yeah, the not really intuitive syntax for you. So this will return a new arg.dat, new list contains for that object. So this is like the non-intuitive part. You can also use this directly, but by creating a static method around it, you can just have code where you say like, okay, list contains. So let's have a look how this would affect our tests. This is like a traditional test you would write, where we're going to test that like, yeah, a list in an argument contains a certain value. So the way that would work is, if we send a message to the user is going to send, yeah, a list of messages to the web service. So here you would then verify that the send messages is called on the web service, so we can capture the argument using, yeah, the technique we did before. Then you have access to the list, and then you can get the value from the list and assert that, yeah, the expected value equals the actual value. So this is the cumbersome way of actually checking that, yeah, an object is in the list parameter. If we now use our custom matcher, you can see everything becomes really clean. All you have to do is say like, hey, Mockito, verify that on this mock, this method is called and that the list contains this object. This makes your test a hell of a lot more cleaner, right? I also have a blog post about that. So if you want to learn more, you can check that blog post. And I'm also building my own library, which adds collection matchers to Mockito. So you could also check that out on GitHub. And I'm basically building a hell of a lot more matchers similar to list contains to basically deal with collections in Mockito. Okay, so testing final and static. Well, let's have a look at another Android-related class. Who here is actually an Android developer? Okay, not that many, but thanks for coming anyway. So this is basically, it's a typical Android class. It's Android.os.handler. What this allows you to do is, it's typically used to move work from one thread to the other, because this basically adds a message queue to a given thread. Now, you don't really have to worry about those details. The main point I want to make is, this is a framework class on Android, so it could also be a library class, and its methods are final. So this means Mockito cannot mock those final methods. So how do we work around this? Well, on Android, the best thing you can do is run these tests not on an Android device, but on the JVM. And why is that? Because the Android tools will then, instead of using the actual Android.jar, they're going to use a modified version of the Android.jar, which has all of these modifiers stripped away. So if you run this on in a JVM on Android, then the finals won't be there while running your test, and then you can simply mock it. Now, if you cannot do that, you still have two options. First option is to create a wrapper class. So basically, we create a handler wrapper, and in its constructor, the first thing you're going to do is you're going to initialize the method you want to wrap. So you initialize a new handler there, you keep track to it, and then you implement exactly the same methods, but you just remove the final modifiers. So this one also has a post and a send message method, but there's no final modifier there. So this would be an approach to be able to still work around that issue. Now, as of Mockito 2.x, 2.1 actually, we now have a way of having Mockito mock the finals for us. This is still incubating, like I said before, so it's an opt-in process. It's quite cumbersome, but it does work. So you need to create a file with a very specific file name, in a very specific path, with very specific content. But if you manage to get this right, then Mockito will mock final methods for you. I also have an example on GitHub where you can check that out. It's currently an incubating feature, so the Mockito team is talking about also providing a programmatic way of enabling that. And who knows, maybe even mocking finals can become the the default behavior for Mockito in the future. So how do you test static methods? This is still something that Mockito cannot do. And basically, here you would use the exact same technique as we did with the handler class. So you're basically gonna wrap around the native class, define similar methods without a static value, and then always call through. Now, I just leave this as an exercise to you guys. This is a part of my open source library, Landscape Video Camera. I have many other interesting techniques to make things testable. And here I test against the native Android camera, which has, a lot of static methods. Okay, now, often in your unit tests, you're gonna need some kind of POJO, which is initialized with valid data. You just need it to feed through the rest of your app so you can actually test something. So how can you provide testing data? Well, simple, right? We have a mocking framework, which can create a mock of that POJO, and then we just stub away every method. Well, that's actually a poor idea, because if you do this, besides being incredibly verbose, this is also fragile. Imagine if I would now remove the getFirstName method from the user class. Then everywhere you did this in your test, all of those tests are gonna break, and you're gonna need to fix them one by one. So you don't really want that. A better way is just creating a new class, a test user data class, and then just override all of the methods in that class and have them return a value appropriate for your testing. This is gonna make your tests a lot cleaner, and this also, because it's just a Java class, if you start refactoring in IntelliJ, it will be smart enough also to remove the methods here. All right, new creation. So what makes things hard to test is basically when you create something new internally in an object. So have a look here. You have the constructor of the user class. What if the user would create the web service internally? Well, that would be a problem, right? Because how can we then mock away the web service for our unit testing? So this actually makes the code almost impossible to test. So in general, you should avoid creating new objects internally in another object if they have the same lifespan as that object. Because the web service is going to be there as long as the user is there, right? So that's not really a good candidate to create internally. So avoid this for long-lived objects. A better solution would be to, instead of creating it internally, just to inject it as a dependency. Dependency injection, at least on Android, has been a bit of a loaded term where there's many people saying, you need to use an expensive framework like Dagger or Dagger 2 to do dependency injection. Well, that's actually not true. You can use the framework, there's nothing wrong with those frameworks, but dependency injection is nothing more than just injecting a dependency in a constructor. So you can already do a very simple thing yourself, and optionally you could check that the dependency is actually injected. I never do that actually, but should you be building a library, then it might make sense to do that. A second interesting pattern is, what if the user doesn't need one web service, but it needs multiple of them? So imagine that you want to create a new web service for every method call you do on the user. Well, in that case, it's better not to, you cannot inject one single web service. So what we can do is we can inject the web service factory, and then every time that the user needs a new web service, it can just call factory.createWebService. And this method we can then mock away in our tests or stub it, so it always returns a mock web service. Okay, then finally some power tips. If you're not writing tests, you're writing instant legacy code. Maybe it's different, or probably it's different in the Java world, but at least on Android, you can see that apps used to be fairly simple. They're getting more and more complex every day. And the more complex a project becomes, the more expensive it was to create it. So the less likely you're going to be to throw it away. So you won't start over as often anymore. So that means that you're going to need those tests in place, because otherwise, over time, you're just going to be fixing bugs of all of the features you already have, and you won't have any capacity anymore to add new features. Especially in a system like Philips Hue, we need to deliver something new to our customers every month. So testing automation is really, really important for us. Now, power tips. Don't use singletons. Singletons store global state in your application, and that can cause stuff like that. The success of one test depends on whether or not which tests have run before it. So then you can get connections between tests. Avoid Android instrumentation tests. So those are tests that you run on an Android device. They're always going to be slower, and they're also likely to be flaky. If you have code that's not tested, like what I showed you before, in my Vue implementation, that code isn't tested. Also in the handler wrapper, that code isn't tested. In the native camera, that code isn't tested. It's not such a big problem to have code that isn't tested, as long as that was a deliberate choice. I isolated all of those code parts to one single class, so it's nicely isolated in a single class. I know that's not tested, and if I would go to that class to see what the class does, every method is just a pass-through, so I can immediately understand what's going on there. So it's a manageable risk not to have that tested. Don't use Mockito spies. I haven't covered Mockito spies here in this talk, and there's a reason for that. Because again, a spy is basically a mock, but it still calls through to the actual object. And you really don't want to be doing that. Because if you do that, imagine if you would have done that for the web service. If you would then call login on the web service, it would actually do a login. And if the login then fails or your web service crashes, then that crash could pop up potentially in the next test or 4 tests later. So then again, your tests are not properly isolated, and you can have side effects from one test in the other test, and that's going to be a mess over time. Don't nest mocks. So if you have a mock that returns a mock, that returns a mock, that returns a mock, that returns a mock, you don't want to have that. Because again, what you're doing there is you're hard coding very detailed knowledge about the rest of your architecture in your tests. So if you were to change your architecture later on, then those tests are going to break. So you don't want that. And avoid using dedicated methods just for the sake of making things testable. Okay, let's wrap things up. So this is from the Mockito documentation, and this is really, really my sentiment about this talk. It's better to have something simple that works than to have something complicated that seems to work. Mockito has a lot of powerful features, but you should rarely be using them. The only use cases in which I use them is if I'm testing against a library of which I cannot really control the interface. So then I need to, I want my code to be tested, but the library is inconvenient to test. So then you need a couple of those power features to make it testable. But wrapping things up, we can say like, Mockito is really easy to use, makes mocking and stubbing really easy. Don't create objects internally because that makes things hard to test. As a team, choose a testing strategy. It doesn't really matter too much what strategy you choose, as long as you're consistent about it, and don't overuse the power features. Unit tests should be small and focused. Consider refactoring. Unit testing code is exactly the same as production code, so you need to treat it with the same care. Otherwise, it's going to bite you later on. And prefer your tests on the Java JVM, which won't really be a problem for most of the audience, I guess. So that was it. I have some references to Mockito and to DexMaker, and I also have quite a few projects on GitHub. In the Mockito example project, you can find any line of code that I showed you here. You can find it back there, and then you can just test it around. So if you want to see how to actually enable testing finals in Mockito 2.0, just check out that example, and you can run it. I have an open source library called Landscape Video Camera, which is completely test-driven refactored, so there's many interesting testing strategies there. And also, I'm creating a new library called Mockito Collection Matchers, where I'm also open sourcing all of those matchers to deal with lists. So the image credits, I wasn't responsible for making all of those Mojitos, unfortunately. So credit where credit is due. And I'm at Mols on Twitter. Feel free to hit me up or ask me any questions. And also tend to blog quite actively on jeroen.mols/blog. It's not only Android related, as you can see, also many just Maven or Java related topics. So thank you very much for coming to my talk. We still have quite some time for questions, so if there's any questions, feel free to ask. No questions? All right. Thank you very much, and have a great remaining of DevOps.